there is a 5% chance that any apple in a crate will have a blemish. If a random sample of 25 apples is taken with replacement, find A, the probability that exactly 2 of these will have blemishes, B, the probability that at least 1 has a blemish, and C, the expected number of apples that will have a blemish. So, the most important thing about binomial probability is recognizing that it is binomial probability. Now, obviously, I've got it in the title, I've got it in the lesson, I'm telling you that's what it is, but in an exam, you're going to have to recognize the hallmarks of a binomial probability question, which are you have a certain number of repeated trials. In this case, the 25 apples that are being taken, that is the number of independent trials. I know they're independent because it says the apples are taken with replacement. So each time, effectively, assuming that the act of taking an apple out and replacing it doesn't blemish any apples, then we're assuming it's exactly the same situation every time. Also, we have a fixed probability of success in this case being the apple having a blemish. So we have a fixed probability of 5% that the apple will have a blemish. So that's the second thing. So you've got number of trials, fixed probability of success, and also on any given trial you've only got 2 possible outcomes. You've got success and you've got failure. In this case, you've got an apple having a blemish or an apple not having a blemish. So once you have those 3 things, you know you have a binomial probability question. So we're going to define the random variable. I'm going to say let x be the random variable. So I'm going to call it the number of blemished apples. Blemished apples. Okay, so once you've got that, it means you can use notation for the rest of the question, which is quite nice. So part A, we are finding the probability that exactly 2 of these have blemishes. So we're finding Px equals 2. Sorry, before I do that, so now we've got that, we can define this variable, or we can write, well, how is this thing distributed? We know x is distributed as a binomial distribution. You can write b or bin, and a binomial probability distribution is characterized by the number of trials and the probability of success. There's 25 trials because we're taking 25 apples in the sample. The probability of success is this 5% chance that it has a blemish, so 5% is 0.05. Okay, so now we can get to the questions. A, we're finding the probability that exactly 2 apples have blemishes. We're finding probability x equals 2. Right, now it should be said, you probably should show a bit of working. I'm going to show you how to calculate this without actually having any working, but it's probably a good idea to have a little bit of working. So hopefully you know enough to know that you have 3 things. So it's the probability of this is going to be, it's going to be, well, 25. There's going to be 25 ways that this can happen because you're selecting 2 from 25. There's only, if you think about this, you could have all 25 apples could be blemished. You could have 24, 23, 22, 21, all the way down to 0 blemished apples. So 25 ways that you can have 2 exactly blemished apples. The probability of it being blemished is 0.05, so that's going to happen twice, and then you're going to have 0.95. You're going to have, if you have 2 successes, you must have 23 failures. So that's a bit of working. I might not show for all, but certainly for a couple. But you can go straight to your calculator and it will just give you the answer for x equals 2. So on the TI, you can go to for distribution. So it's just, you see this vase button here, a distribution. By the way, now we're sort of getting through the course. There's a lot of different places to look for things. On a TI, if you're ever not sure where a function is, if you go to catalog down here, so second and 0, you will find everything there. But I'm going to go into distribution. But I could get to it exactly the same way. to get to exactly the same place using catalog. So I'm looking for something to do with binomial. I'll keep going down, down, down. And I can see now I've got this binom PDF and a binom CDF. Let's just have a look on the Casio as well. So on the Casio I would be in menu and statistics. And I can go straight to distribution here if I just press F5. And it gives me the option normal, T, chi, and then I'm going to go to binomial. And again, I've got a BPD and a BCD. So your BPD corresponds to, well, it's the same thing as the PDF for binomial. And the BCD is the CDF. So it's a probability distribution function, cumulative probability distribution function. So for the PDF or the on the Casio a BCD or BPD, you use this when you're looking for X equals something. When you're looking for the probability X equals an exact number, you use CDF or CPD, or sorry, BCD. You use those when you're looking for the probability X is less than or equal to something. So, in our case for part A, I'm finding the probability X equals 2. So we want the PDF on the TI and the BPD on the Casio. So on the PDF, I need to tell it that we're having 25 trials. Probability of success is 0.05 and we're looking for the probability X equals 2. So I've already put those in on the TI, I haven't done on the Casio, so we'll go BPD, and it's slightly different on the Casio, it's very different actually. You need to make sure you're on variable and not list. So if you press var, then it looks a lot more like the other one. So you choose X, we're interested in X, probability X equals 2, there's 25 trials, the probability is 0.05, and then we are ready to execute. For the TI, just click through, and both of them give us an answer of 0.231. You should give it to 3 significant figures unless instructed to do otherwise. 0.231 to 3SF. B. The probability that at least one has a blemish. So that means you're finding X is greater than or equal to 1. Now, if you were doing this kind of longhand, you'd say this is sort of 1 minus P X equals 0. Because if you think about it, as I mentioned earlier, you can have 25 blemished apples, 24, 23, 22, 21, all the way down to no blemished apples. And if you added up all of those individual probabilities, because it's a discrete thing, you can't have 25.5 blemished apples, for example. If you added them all up, it would add up to 1 because it's all possibilities. So what I can do here, I know that the probability that X is between 1 and 25 is going to just be exactly the same as 1 minus the probability X equals 0. So I can now work out the probability X equals 0 equals 1 minus, if you think X equals 0, well, it would be 25C0, which you should know is just 1, times no blemished apples, so 0.05 to the power 0 and 0.95, all 25 apples would be unblemished. So it's basically 1 minus 0.95 to the power of 25. Looking at the calculator, we could potentially use a BCD for this. You can do it either way around. You can use a BPD or a PDF and just find the probability X equals 0, then take away from 1. Or certainly, if we look on the Casio, you can, if we go out of that and go to the binomial BCD, the variable is still kind of there, upper, and it gives us this lower and upper. So it's showing what's the upper bound. Well, that would be 25. and the lower bound, sorry, would be 1, and the upper bound would be your 25. So you're finding the probability x is between 1 and 25, and it'll do all the work for you. And you can see it's quite high, 72%-ish. Let's see what options we get on the TI for that sort of thing. So if we go back to distribution, go down, and on to binomial CDF, and this is not the same. So basically, for a TI, you can only do the probability x is less than something. You can't find x, put x in between two values, certainly not on a TI-84. So if that's the case, well, you might as well just go back and find the probability x equals 0. And it'd be quite good because we can check it with what we've just done. So if we go back into the BPD, or PDF on the TI, we have 25 trials, probability of success 0.05. The x value we're interested in is 0, and then let's have a look at that. So that comes out as 0.1 minus 0.27738, which gives us an answer. Oh, if we just do 1 minus ANS, 1 minus ANS, and it gives us exactly the same answer as we had from the other one, which is reassuring. Remember, 3 significant figures, 0.723 is the answer to 3 significant figures. For part C, we need to just find the expected number of apples that will have a blemish, which that's definitely, I would say, the easiest question of the lot. Remember, the expected value of x for something with a number of trials, independent trials with a fixed probability of success, is just NP. So in this case, it's N25 times P 0.05. So you're just finding 5% of 25, which you could probably even do in your head, or 10% is 2.5, and so 5% must be half of that, so it equals 1.25. So that means that you would expect 1.25 apples to be blemished, which obviously is impossible for 1.25 apples to be blemished. But say you had a giant sample, or you kept doing these samples week after week after week, on average you would expect this many blemished apples per 25 apples.